Welcome to a new video in my Weidmüller Automation Controller series. In this episode, I'm going to give you a beginner's guide to Node-RED and especially how you would use Node-RED on the Weidmüller Automation Controller. Node-RED is a complete development environment. It is not really something that I can just show you in a single video. So I think what I'm going to do is I'm going to talk about the absolute basics, how you can get started, and then how to navigate around in the editor and how to find information if you need to. And then probably we are going to jump right into the details and then see how you can do some basic interactions between the Node-RED and the PLC, and actually how you to use these Weidmüller specific nodes that are provided with this Weidmüller installation. If you already know Node-RED, you can jump this section. You can look at the contents either in the video description or at the beginning of this video. As I said, Node-RED is a complete development environment, and the fact that we have some boxes on the editor and we can connect them using lines that are called the wires should not make anyone to think that this is a development environment where you can just, connect boxes without writing any code and not to think about how the computers work, because what I at least find in most cases that you will end up doing small bits of programming besides using these boxes. And even in my sample 4 that I'm going to talk about now, there is a fair bit of JavaScript code included. So I'm saying that if you are serious about using Node-RED, I think you should have some sort of programming knowledge, and you also have to be aware of at least the various data type and basic concepts. For example, what is a JSON, what is an object. And as I already mentioned, the programming language in Node-RED is JavaScript. And I know JavaScript is polarizing, and for some people that's just evil, but actually I'm quite happy with it, and I got quite used to programming in JavaScript, and well, actually using Node-RED. I quite like the Node-RED environment. If you are completely new to Node-RED, there are some really good tutorial videos also in YouTube and in other places as well. And I mean, those would take a couple of episodes to get from the basics to some sort of advanced level, but I'm going to talk about the basics here as well. And the other good resource if you ever need help is, well, it's obviously node-red.org, and in here I would talk about two main things that you should definitely find. Well, first of all, you have some documentation here which talks about frequently asked questions, getting started, how you use the basic nodes, and how you send messages and that sort of stuff. The other thing is there is a quite extensive forum, and some of the founders who are actually working in Node-RED are also contributing in the forum. And whenever I have questions, I mean, I personally find an answer, or at least some sort of comments which guide me to the right direction in a couple of hours, or let's say in half a day. So this is definitely something that I can recommend, and there is a lot of useful information here already, and this is a lively forum, so you will always get some support. And the third thing is the flows, because as I mentioned in the first episode, you can install additional nodes into your Node-RED. And when you do that, you will, and we have seen it here, that you can add new functionality by installing new nodes. And these nodes are available here in the library. So for example, I know that there is a node that I like a lot. It's a big timer, and it is a node about, well, as it says, it's timers. So if you type big timer here, you will find references about if it's an actual node or actually some sample programs that somebody has done with this. So if I just look at the big timer, then you can read about the the big timer. So if you install, you get this additional node which looks like this. And usually within this write-up, you also see how it needs to be used, and you have some couple of examples. I mean, this particular page doesn't have a lot of examples, but most other pages even have screenshots how you use it. So when you want to add something like this, for example, if you think of if you get a mention that this is a new node, then you can just type it here, big timer. And if you want to install it, you click install and then install, and you have to wait for a couple of seconds, or depending on how big the node is or the extension is, it might take you a few minutes. But sooner or later you would have this big node installed, and you would have an additional, box here in your catalog that you can use later on. The other thing about the whole flows is that when you look for, again, if I search for big timer, as you can see, there is a node which is called a big timer, but there are some additional stuff that, for example, how somebody has used the big timer to do terrarium automation. And if I click on this one, again, there is a write-up about what this sort of article is about, and how the automation works. And then finally you find this code in here. And this code is actually called a flow. And what this does is, if you go back to the editor, now I think the big timer has installed. Actually, let's just check that. Yeah, you see now the big timer is available. It wasn't available before. So what you can do with this flow is you can just copy this entire code. So it always starts with the square brackets and also ends with a square bracket. And what you can do here is you can come here and then you can do import, and then just paste this code in here, and that would import your flow. And that's a really nice and easy feature, how you can import, export part of your programming or part of your flow in here. So for example, if I have some issues with this particular program here, I can just select it and I say export the selected nodes, that are the ones that I selected. As you can see, that's basically the text version of this flow that I have created. And for example, you can send it to someone in an email, you can post it in a forum, and somebody would be able to import it in the very same way. So if I copy it to the clipboard, and then by the way, if I import it straight away, I just paste it in and I look at import, you see my exact copy of the flow that I've exported can be imported. So that's a really nice and easy way to export code and then basically share code. And this was the third thing that I wanted to highlight here, that besides extensions of nodes, you can also find a lot of flow where somebody has done a piece of automation or a piece of logic in Node-RED, and they are just sharing here in the Node-RED flows. So this was all I wanted to talk about, how you get support and how you get started if you get stuck with Node-RED. So let's get back to the actual Node-RED. As I mentioned previously, this user interface that you find here is the actual editor. This is how you can create programs. And when you look at it first, that the fact that you have boxes and lines in the editor, you might think that it works exactly the same way as the function block editor that we have seen in the real-time application. And well, this is just a UI thing, because actually I think it works quite differently. Probably the only similarity between the two, that again, you have boxes. It's called functional block in the real-time programming. Here in Node-RED, they are just basically called different nodes. And the idea behind the nodes, just like the functional block, is that they provide a set of functionality. So they have some input values, and then they would do something with that input value, and then send the result in the output. And in the visualization, you also see that you have these nodes. They usually have a dot on the left. Well, sometimes they have a dot on the left, and they also have a dot on the right. So the data goes in from the left, it does the processing inside, and the data goes out. And this is where the big difference is between the functional block programming and Node-RED. Because in the functional block programming, these lines, they would have a certain value at any point in time. Let's say if it's the input of a push button, then it would have either 0 or 1, depending on the physical state. In Node-RED, in these lines, there is usually, I would say usually nothing, because on these lines or in these wires, messages travel. They don't have a fixed state, but sometimes, a message comes through. And let's look at the example just to understand a little bit better how these messages work. So I've taken the last example, the iodata-out. And as you can see, if you just hover over, it says that this node can be used to write values to one of the global variables. So what I have done now is I just drag this onto the editor. I've already done that. And usually for every single node, if you click on that, you can see some help information here. So here in the info page, and it tells you about what sort of inputs it's expecting and what are the outputs. But usually when you double click it, you would have some properties page where you can edit the properties of this node. And the only thing we can do here is we can set up what is the global variable which will be written. So here it's called the out8, and if you remember my previous videos, this is one of the digital outputs on the first output card or the output module. So with this we can write that output. And here in the actually in the input it says that on the input side it expects a payload which is a JSON which contains the property value, and of course because it's a digital output, that value can be either true or false, you know, if it's true if it's on, and it's false if it's off. And if I want to send the data in, what I can use in Node-RED is I can use the inject node. And here in the inject node I can, you know, obviously specify what I want to send in. And because this iodata-out node tells me that it expects a JSON, I can configure the this inject node to send me a JSON, to send in a JSON, and the JSON looks like this. So it has a value property, and that property has a value of true. So JSON starts with curly brackets, the properties are in double quotes and colon, and the property value. And what I can do with this inject node is if I click on this one, then it actually sends that data in. So when I click, this message goes out from this inject node into this iodata-out. And well, actually I haven't set up the camera yet, but probably you can believe me that on the 8 output on the digital output card, it has turned on. So I just turn it on. And if I send a value of false, then it actually turns off. So very simple. This is how I basically, you know, switch a global variable on and off, which of course, because the global variable is connected to a physical output, it switches the physical output on and off. And all this is done by these 3 nodes. But I have some other nodes connected here. So on the output of this IO data, it also sends me some data out, which I have directed into this debug node. Okay, and you can find the debug node here. And all this debug node does is we have a debug tab, which is this bug, and then whatever you send into this debug mode gets displayed here. So if let me delete the logs. If I set it to true, then I get a message. And if I set it to false, then I get a message. And since we are here, let's just talk about these messages, because these messages have a very important structure. So these messages are called, the name of this message variable is called MSG. And it definitely has one attribute, which is a payload, and it's mandatory that it has a message payload. It also has a topic, but at the moment we are not using the topic, we are going to use it a little bit later. And this payload can be anything. So this payload can be a text like, hey, hello world, or it can be a number, or it can be an object. For example, here we can see that the message.payload is an object. And this is why I was saying that it's important that you understand these programming principles. What are the different data types and what is an object? So, and what I'm getting in this object is, this is something that this node has prepared for me. So it tells me what are the variables that I have changed, that's out8. What is the value that it got changed to? So this is when I turned it to true. And what was the timestamp that it was happening? And that's it's a JavaScript date format. And this is when I turn it off. So it basically just tells me what it has actually done. So I can use this information for debug purposes. And if I want to talk about this structure a little bit more, and how you send data and what you can do with the data, let's say I want to switch this output using a more, let's say, a simpler data, because preparing this JSON with this particular value and the attribute value and the actual true or false can be a little bit complicated. What if I have a very simple data which only the payload only includes a number. So I will say that, my payload previously was JSON. My payload is now in a number because I just want to, send ones and zeros to turn things on and off. So then what I can do is I have a switch node. So this is a standard switch node which says if my payload is 0, if it's number 0, then redirect this message on the first output, and if it's 1, redirect it on the second output. So basically it splits the data either to this wire or to that wire. And here what I can do is I can use another node, which is the change node, and say that, if it's 0, I think the first one was the 0. If it's 0, then I change my payload to this particular payload. That's the the payload and the format that my Weidmüller out node expects. And if I want to turn it on, that's the data that it expects. So basically it just replaces the ones with the value equals true. And if I click on here, then again I can see right at the end of the flow, so it goes like this to here to the debug, that I have actually turned the output on. And if I click on turn off, I can actually turn the output off. By the way, the reason it says turn on or turn off, because whatever you put in the name, that actually appears on the editor. So if I can override this to out8, it doesn't impact the functionality, but now I can see that this is out8. And since I made some modification, now you can see that a blue dot appears on top of the node. This means that this node has been changed from the deployed version, and a deploy button appears on the top left, on the top right. So you are making some changes, you see these blue dots. Even moving some nodes around means that the flow has changed, and you just hit on deploy, and those changes would be sort of like written into the program. That's it. I mean, we haven't really done anything, so it doesn't really change how the program works now. So with this, hopefully you can understand how to inject data, how to debug, and then how to wire these boxes together. And of course we do have a lot of boxes. That's why I said that we can't possibly go through all of them in even like in a couple of videos. So I'm just going to focus on the basics. Let's talk about the next node. This is the iodata-in, which can be used to, well, as it suggests, fetch global variables from EU control. And this doesn't have an input. So basically you just place this node, and you can specify whether you want a single variable to be fetched or you want all the variables. I think in most cases we want single. And you can see that we have a selection of all the global variables that we have selected previously. I selected out2, and you can specify the polling interval. So this node is going to give you the status of the out2 every single second. So not the changes, but the actual state every single second. That's why this node says that make sure that you set this polling rate according to what you want to use it for. So at the moment I'm setting it to 1 second so we can actually see these changes. And when you are learning about a new flow, or actually you are doing something, I encourage you to always use debug nodes, because this is the easiest way to see what is happening. So now I just place the debug right after the IO data. Of course you can send the data in multiple ways, and now I can see what is really happening, what is the type of data that I'm getting out from this node. And again, if we see that the payload is an object, if I extend, I can see that the name is out2, the value is either 0, in this case is 0, and if I would turn the output on, let me do that, I just press the button, you can see that the output turns to 1. So now we can see that in the message.payload.value, because that's the value property of the object, we can see either ones or zeros. So what I can do again here is, technically I don't really care about the data type or the name, because I've just specified that I want the out2, I know it's a bool type, and I don't really care about the timestamp either. So all I want to do is I want to use the value going forward. So what I can do is I can again use a change node and then say that, okay, my payload now needs to be the message.payload.value. What I also want to do is I also want to convert it to a number, because you can see here that the value is in double quotes. So, double quote 0, which means that it's actually not number 0, it's the letter 0. So if I want to, let's say, use in numerical calculation, you have to convert it to an actual number. And I wanted to use this opportunity to show you that here in the change node, you can make changes. You can set the payload to specific values, or you can also use an expression. And here it's you can build a simple expression, and you have actually quite a few different functions here that you can use to slice a string together, convert text to uppercase, lowercase, and also all sorts of mathematical functions here. So par, random, and more text functions, for example, replace. And this is called the JSONata expression editor. So you can again Google JSONata to get help on any of these functions and how they get used. So all I'm doing here is that I'm replacing the payload. So instead of this big object, it just contains the value of 0 or 1 in a number format. And if I open the debugger, say enabled, you can switch these debuggers on and off. So if I change the output pushing the button, you can see that now my message, instead of being all these different objects, is just a simple zeros and ones. Next, what I can do is, let's say, I don't really care about all these ones and zeros every single second. All I really care about is just to know when it actually changes from either to 1 to 0 or the 0 to 1. So what I can do here is, Node-RED has provided us a really nice tool which is called the RBE, and here you can specify that I want to block the messages unless they change value, and they should be looking at the payload to see what has changed. So what is happening here is, if let me delete this. If I open this debug, then there's no message, there's nothing coming through. But here we can definitely see that all these zeros are coming through, but they are being filtered here by the RBE. So what happens if I push the button? Now we get 1, because it changed from 0 to 1, so we got 1 message through. And of course, if I turn it off, then we get one of the zeros through, but not any consecutive ones or zeros. Okay, that's good. So now what I want to do is, I have this output. So now I'm getting information when this output is getting switched on or switched off, either by a different Node-RED flow or one of the real-time programming examples, or from the visualization. Doesn't really matter. All we are doing is we are looking at the direct output. Let's say this output is connected to a pump, and this pump has a maintenance period. So we want to measure how long this pump is running. So we want a counter which counts every time that the pump is on. So that's the best way of looking at the direct output, because we don't care how the pump gets turned on, or we care about if the pump is on and off. And because Node-RED is not like a home automation system or not a home automation product, it's just a general development environment, of course we don't have a box which actually counts time. What we have instead is we have a generic box which is called a function node, or general node, which is a function node, and this is where we can do some JavaScript code. And I'm going to open this, and I mean, it's not like a 2-line JavaScript code because it's doing quite a lot, but once you understand JavaScript, you can pretty much read the whole thing. And what this JavaScript code does, it's looking at the data that is coming in, it's looking at the payload which is coming in. And if the payload is 1, then it saves the time when this message came through. And when the payload is off, then it basically looks at the current time and the time when the payload 1 was received, and from the two it calculates the number of seconds have passed. And it also puts the seconds on the screen, and it also passes that uptime on the output. So if I look at how this works, now you can see that my output is off, and it has so far counted 25 seconds. If I turn the output on, you can see that the number, the payload 1 has arrived. Then this status here changes to a green dot, and then the number of seconds starts counting. And also what we see on the output, that every second it is also sending me an output which contains the actual uptime. And if I turn the output off, then we receive the 0 payload and the counter stops. And we can also see that the status changes to this blue ring, so it visually tells me that it's off. There are two things that I want to talk about this function node, or well, this particular function node, without actually going into the JavaScript code. First of all, that messages are coming in, the either ones or zeros, which tells the code that what was the time when it turned on and what was the time that it turned off. And every time the message comes in, this JavaScript code is executed. So in this JavaScript code, I have to look at what is the message which is coming in. Is it 1? Then I know that the device got turned on, so I need to start counting. And if it's off, then I need to do I need to stop the counting, and I need to count how many seconds have passed. And when the message comes in, this piece of JavaScript code is executed and it finishes until the next message comes in. So this function node also needs to store data. So when the next time it is executed, it knows things. For example, what was the time when the on message came on. And this can be done in a couple of different ways. Again, if I go to this sidebar, I can go into the context data, and this is where I can see data that my program actually stores. So these are, let's say, the local and the global variables in Node-RED. And they are not exactly called global and the local variables. They basically have three different distinctions. We have some global variables. I don't think that I have any. These are the variables that any node on any of the flows, because as you can see, I have multiple tabs. I can have as many tabs as I want, and these are called different flows. So global variables are visible by all the flows and all the nodes in every flow. If I want to restrict the data only to my flow, which is now called flow 1, then I can define it as a flow variable. Oh, I don't have any flow variables either. Or the third option, the least limiting option, is actually the node variable. And here I have two node variables. Actually, let me turn on the output. And now I can see that I have two node variables. So these are the variables which only this function node can see. So here this function node stores two data here. It stores the on time, so this is actually the JavaScript timestamp when I push the button. Well, not actually when I push the button, but when the first one message came through here. And then also it keeps counting the uptime. That was the uptime when I started the calculation. So when the off message comes through, it knows that, okay, that was the time it was turned on, so it can calculate the difference and update the uptime. But what you can see here is that even though I haven't turned the output on or off, I'm still getting all this uptime updated here on the screen. And this is happening because I also have this second inject node, or well, second in this flow here, which it says update. And what I have done here is I've configured this inject node that it executes every single second, because that is the only way to make this program trigger every single second. So I get an update on the screen for every second when the output is on. So here you can configure this repeat to interval every second. And also what I have done, something that I've mentioned before, is the topic. I have specified a specific topic here because all the messages that are coming through here, they actually have, let's go back to the node. Oh yeah, you can see here that they just have a payload, they don't have a topic. So here I'm sending a message in where the topic is update. Actually, let's just see how it works. If I just right click here, I have a simple pop-up. So I want to put a debug node in here. And if I execute, and sorry, if we deploy, then we can see that out of this deploy node, if out of this debug node, we can see that this inject node is sending a message in every single second. As you can see, the payload is just a number, it's a timestamp number, we don't care about that, but the topic is update. And in this code, what I can do is, if I receive a message where the topic is update, I know that, the device is either still on and off. All I need to do is I need to update the uptime here. And for me, this is one more key aspect of how you think about, messages and screen updates. Sometimes you need to have incorporated these inject node into your flow in order to make your, program to do something in between where you are, let's say, receiving useful messages. But enough about the count time. So it counts how many seconds this output was on, or let's say in our example, how many seconds our pump was running, and it sends this information out on the output. Again, you can see that the payload actually contains the number of seconds. So what we can do, again, we can use a simple switch node which says if the message.payload is, actually I should have said, greater than the number 200, because let's say, it's not a good example, 200 seconds is not a maintenance interval, but let's say that's the maintenance interval. So if the counter has passed 200 seconds, then I need to send an email. And again, we have a simple email node which can send me an email, and here you can read about how you send the data into the email node. I've already done that. So in the message topic, you have to send the email subject, and in the message payload, you have to set the email body. So I have done that with, again, a very simple change node. So I say the topic, which is the subject, is the pump maintenance required. The payload, which is going to be the email, the pump runtime has exceeded the maintenance interval, please schedule maintenance, something like that. And you send it into an email node. I haven't configured the email node, but you have to set your, email address and user ID and a password. And it's already defaulted with, the Gmail settings, but of course you can change it to any other email provider which supports SNMP on either secure or non-secure connection. So this would be a very simple example how you implement a runtime monitoring on a device and act something upon, when the maintenance schedule is due. And either for me to carry on with the Node-RED introduction using some of the Weidmüller nodes, the next one I want to continue is the channel data. And the channel data is very similar to the iodata. In the iodata, you can specify all your global variables or one of the global variables. The channel data is almost like all the global variables, but instead of the global variables, it actually pulls the data directly from all your input channels. And here, let me just go to the debug node and turn this off so we don't get any additional messages. And I go into the setup. So the only thing you can set is what is the polling interval. So let's say 20 seconds. And we just need to wait for 20 seconds or the next 20 seconds. And I turn the output on so we can see how one of the input looks like, or one of the data looks like. And what you will notice that it's going to be an array of different objects and only containing the slots that are the input ones. So now we can see that actually we received an object, it's not an array. So we have slot, it doesn't have slot 1 and 2 because those are the output cards. So we have the slot 3 and 4 that are the two inputs, and actually none of the buttons or the switches are a switch, so all the values are 0. But if you look at 6, which is the digital input card, and we look at the channels, we can see the analog input value which is coming from the pressure sensor. So you would use this channel data if it's absolutely important that you get all the channel data at the same time. Maybe if your calculation or your triggering is depending on getting all these data synchronized at the same time. So then you can use the channel data for that. And finally, the last node in the special Weidmüller nodes is the aggregation. And this one is not even connected to any of the, the physical PLC inputs or the output. This basically just contains mathematical functions that we might want to use to describe our data. And if I look at the info pages, you can see that it expects the input value or the input payload in an array, and in the settings you can specify what the output should be, whether the output should be the sum, the minimum value, the maximum value, the range, the average value, median variance, or the standard deviation of those values that are coming on the input. So if I want to do a simple example here, I've created the inject node. So this is inject node is just a timestamp inject, and here on the change node I just wanted to show you how you can just replace it with a fixed value. So all I'm saying here is a very simple 2-line JavaScript code. Is my message.payload equals an array which contains the number 1, 2, 3, and 4 and 5. So basically 5 numbers, and then return MSG means return this message onto the output. So unless you have the return, there's nothing goes out in the output node of this function node. And we pass it into the aggregation, and this aggregation is set to sum, and we should have the value at the end. So if I click here, I send the timestamp, which gets replaced with the array, which gets aggregated. So hopefully we'll get a number which is 15 at the end. So this is 1 plus 2 plus 3 plus 4 plus 5. So that's how it works. It's fairly simple. I wanted to take it to the next step, and I've included an iodata-in, which gives me the pressure value. So that's the input, analog input value from the pressure sensor. I'm going to get it every 5 seconds. And again, I'm going to just remove the rest of the the payload and just convert the value into a number, because we are going to collect this number into an array. And again, this is a piece of JavaScript code. It looks complicated, but it's really not. All it is doing is it starts collecting this data, and it puts it into a 10 element array. Up to 10 element array. So if I activate this payload, then we will see these numbers coming in, and you see 91, 91, 70. And then what it does is when the array is already 10 elements full, it starts to lose the first number and then push the actual number in from the right. So all it does, it keeps the last 10 reading from this pressure sensor. And of course, if I turn the other debug node on, we can see how the aggregation, I've set it to average. So it creates me an average value of the last 10 readings. And to be honest, since I've done all this JavaScript code to actually collect the data in an array, I might as well just calculate the average as well. But well, there are other ways to collect different data. As it says here in the input, maybe you have various data coming in from different sources and you join together. So there is a join node which actually joins multiple messages together, and you can specify that join that it joins them to an array. So if you are getting various values in a payload, this join can put them together into an array, and you specify that you wait for I don't know how many seconds until the since the first message comes through, or you wait for a count of messages, and then the jointed message gets outputted at the end of the node. And I think this would conclude the Weidmüller Node-RED overview video. There will be other videos where I talk about Node-RED, and those will hopefully give you more ideas of how you can solve various issues in Node-RED, and probably I can also highlight a few more programming ideas in Node-RED as well. Just like before, if you have questions, please ask them in the comment section below. Also, because I talk about how you can export this flow, I'm going to export this flow using the export functionality. You can export entire flows as well, and I'm going to save it in a file, and you will find the link to this file in the video description. Thanks for watching, and hopefully see you in the next video.